Thanks very much for joining us for this edition of the Intermodal Logistics Podcast. I'm Kevin Baxter, joined by my co-host, Rick Lagore, the Intech Logistics CEO. Hi, Rick. How you doing?
Doing great.
And so today we're going to discuss some tracking technology that you probably have heard of, RFID. That's a term that's been around for a while, but there's a little twist to this one that you may not have heard of. And joining us to discuss that is Eric Biel, Director of Strategic Partnerships with Powercast. Eric, thanks very much for joining us.
Oh, I'm happy to be here. Thanks for having me, guys.
And so we always like to start off with a little bio. So tell us a little bit about your background and your role with Powercast.
Sure, happy to. So went to the University of Pittsburgh. Powercast is based in Pittsburgh. And interestingly enough, Powercast was spun out of the University of Pittsburgh with some of the initial research in RFID. So it's all kind of full circle here. So I went to Pitt. I worked at Powercast as an intern while I was at Pitt in the engineering program there. I was their first hire of an intern out of the University of Pittsburgh. I worked here for a few years. I left, went across the street and worked for a medical device company for a few years, met my wife there. Then Charlie Green, our CTO, was like, hey, what are you doing? You want to come back? So I came back and I've been here ever since. So going on maybe 12 years with Powercast in various roles, most of them very technical on the engineering side. And now I'm in this Director of Strategic Partnerships role. I like to view it more as like a sort of a firefighter, right? What's the biggest fire? Help put it out, whether that's on the technical side, a business side, a legal side, whatever it is. I just try to help keep our customers satisfied.
And so tell us a little bit overall then about Powercast, what Powercast does.
Absolutely. So Powercast is a wireless power company. So a lot of folks are familiar with wireless power when it comes to sort of the Qi charging that they find in their phones, where it's contact based with coil to coil sort of charging. We dabble in that, but really our core technology, what we've been doing since 2003 is far field radio frequency transfer of power. So we're sending power upwards of 120 feet through the air is the furthest we've gone, powering everything from sensor devices, very low power, duty cycled IoT devices, things that run on coin cells, to consumer electronics like remote controls, video game controllers, keyboards, mice, headphones, all those sort of peripheral devices. And more recently, we've expanded our platform to include magnetic resonance charging as well, which is basically, think of the near field Qi charging, but a little bit on steroids. You get further range, you get the same amount of power transfer, much more freedom of placement. So basically anything having to do with transferring power wirelessly, we play in.
So what are some examples? I mean, you talked about some general examples of, but how about like a product that somebody might have already used and not really realized that it's been happening?
That's what's interesting. So power in general is so horizontal. We're in so many different things. I'll speak. The biggest consumer deployment we have to date would be in the Samsung Eco Remote. So if you buy a Samsung television, the remote control that comes with those TVs, they had a big green initiative where they wanted to eliminate battery waste from those remote controls. I mean, people throwing AA's away over, or AAA's away over and over again. So they use a supercapacitor in there. And there's three means of recharging that supercapacitor. One is USB-C, you can plug the thing in. There's a solar cell on the back, but then our chips, our semiconductors are in that device harvesting from ambient Wi-Fi and Bluetooth signals to top off that supercapacitor. So if you are within range of a Wi-Fi or Bluetooth signal, it's going to capture that, harvest what it can, and put it into that supercapacitor. So there's a huge millions and millions of units of deployed there that most people would have no idea about, right? It's not necessarily the selling feature, but it's there helping to keep that thing topped off, and also from a sustainability standpoint, eliminate that battery waste. A second example, we do dabble in some of our own products here at Powercast. We have a video game controller that we made that's compatible with the Nintendo Switch controllers. The number one story we hear from folks here with kids is, they pick up those controllers, they're dead every time. If you don't dock them to the docking station, the batteries are dead. And that's where we come in 99% of the times, is the batteries are the pain point. So we made a little grip that you dock those controllers with, but then the real magic is that grip is then wirelessly rechargeable. You set it down in front of one of our transmitter devices, and then you're never having to plug that thing again. So when you're not using it, it's just sitting there and you're topping it off. So without any interaction on your part, you're getting that wireless charging, and hopefully never having to dock the controller to recharge a battery. So two instances there, just a couple things we dabbled in the consumer side.
Yeah. I mean, it's just interesting to think about the broader applications with people walking around with smartphones in their pockets all the time. If they could all have that little top off all the time and not worry about zonking out quite as quickly.
Yeah, that's sort of the dream, right? Is no cables everywhere, right? Cables are a competitor for us. We're very upfront, though. I think a little bit more so than some of the other folks that play in this space about what the technology can do. Maybe more importantly, what the technology can't do. And the number one question I get asked, whether it's at a trade show or whatever, is, can you charge my cell phone through this far field RF technology? Answer is yeah, absolutely. But given the limitations that are put on us by governing bodies like the FCC that limit the amount of power we can transmit, you're essentially limited in how much can ultimately reach the end device, therefore limiting how fast I can charge your phone. So if I told you it's going to take you 18 hours to recharge your phone, it's not a real good use case. So we don't actively go after those kinds of things, though it is technically feasible, and it's not a limitation of technology, more so on the regulatory and regulation side of things. But from the consumer side, we go after all those other peripheral devices, all the smaller things, that the smartwatches, the fitness bands, where you've got a ton of chargers you can around to keep these things topped off. All those are great examples where wireless power in sort of an overnight time frame gives you full battery kind of thing.
Yeah. So we're talking consumer, but let's swap to what we're really focusing on here today. More about the RFID and the supply chain freight usages of it. So where is that coming in right now today?
Absolutely. I'd like to talk about that. So I kind of touched on it at the beginning, where our core technology was spun out of RFID research, because every RFID tag, and I'm talking about UHF RFID tags in the 900 megahertz kind of range, have a sort of harvester in them that converts RF energy to DC power. And those tags typically don't care about how efficient that harvesting is, because they only want enough power to run their state machine and to report and communicate the backscatter and all that kind of fun stuff that they do. And the whole idea of Powercast was like, well, what if we could make that harvesting very efficient and then use the additional power to do other stuff too? Right. So we're heavy players in the RFID space, not just in the traditional tracking of things, which is vastly important, obviously, in terms of logistics and supply chain, but we can enable what we call higher function RFID at the same time, where you're getting tracking plus something. Maybe it's a temperature sensor measurement, or maybe it's humidity, something like that, where you have additional power. So why not use it? One of the most interesting ones that people like on some of the tags that we have made in the past is a Find My Tag feature, which is simply completely passive tag that will blink an LED. So if you have 100 tags sitting on a table, how do I find tag 74? Well, you can tell that tag to blink, right? And because you have the power to do that, now you're not sifting through or reading labels to try to find a specific tag. So that's kind of where we sit in the RFID space, is enabling additional functionality on top of the traditional tracking you get with RFID tags.
So back in the early 2000s, so I'll date myself a touch. So I was in the warehousing world. RFID technology came out and said everything is going to have RFID tags. That never really occurred. So kind of where does RFID stand, and how prevalent is it out there today?
It's very prevalent. So it's in a ton of things. Now, is it on everything? No. Does it make sense that it's on everything? No. But there are other means of tracking things depending on what that item might be. You might use QR codes, you might use NFC tags, you might use RFID tags, and they're all have their specific use cases. But what's interesting is I don't see anything slowing down on the actual RFID side of things, particularly with some of the stuff that we're seeing in Europe with the digital product passport that they're implementing over there, where every item is supposed to be tracked. You're supposed to be able to tell, um, you know, data about a product on its journey, like its material sourcing, end of life recycling information, basically everything that has to do with that product lives with that product in a way that you can extract that data, know where it came from, what to do with it, where it was manufactured, its serial number, its model number, all of that stuff. And that'll be in everything from batteries to textiles. So some applications might use a NFC tag or a QR code for that. That's great. But like on a textile situation, if I'm going to wash a shirt, how am I going to maintain the readability of a QR code through, hundreds potentially of cycles? So there's applications for these things all over the place. And given existing infrastructure that might be in warehousing or in airports, it just makes sense to implement an existing technology to leverage what you've already got out there.
Right.
So are these like purpose built tags then from you, or you can then adapt tags that are already out there as well?
So a little bit of both. Maybe not the easiest answer there, but I'll explain a little bit. So we can take an existing tag or an existing IC, and that made by a third party manufacturer, and we can kind of work in parallel with it. So where you share maybe one antenna with the tag for its communication, but then we also share that antenna for power purposes where we can enable higher functionality. And then at the same time, we also have do our own designs. So we'll make our own tags in some instances as well. So some of the products that we make now are doing that parallel thing where we're taking an existing IC and working with it, but we're also at the same time researching our own tags to enable basically enhanced functionality in one package, right? Get costs down that way, things like that too. So depending on the application and the customer, we have different approaches we might go down for different, end use cases.
So on the tags itself, how far from a scanner does it have to be, or what's the distance that you need to be within to be able to pick it up?
So for completely passive, you're looking at like 30 feet. 10 meters, that's sort of like the range you're looking for from and when I'm saying that, I'm assuming basically North American style transmit level, so 30 dBm with maybe a 6 dBi antenna on this thing. So what you pretty much find in any RFID reader you buy off the shelf in terms of power level. The less power you have, the closer you get. Then if you are pairing the device with a battery and doing sort of battery assisted with these tags, you can get additional range and the ability to do maybe data logging out of those fields. So if you're out of range of a transmitter, you can still do whatever it is you're trying to do. And what we'll do in some of those instances is if we do have a battery on board that say you're doing something like cold chain, right, where you're tracking a pharmaceutical or something that needs to stay cold throughout its process, you need power all the time. So you're probably going to have a battery with this. What we'll do in those instances is rather than having to plug in this thing to recharge a battery or making it single use, we'll wirelessly recharge that battery. So similar to the wireless game controller I was talking about earlier, we can do wireless recharging of these batteries in these data logging tags where you can charge many of them at the same time by simply placing them in front of an RFID reader. So something goes out, when it comes back, you just set it in front of your reader, it tops it off overnight, you're ready to go. No plugging 100 tags in, you just set them down in maybe a table or something and recharge them all. So that's the kind of interesting thing we can do with battery assisted tags too.
Got it.
You mentioned food, or you mentioned temperature controlled, and you just mentioned cold chain with pharmaceuticals. So that temperature control and temperature monitoring element has got to be a major point of emphasis there going into the freight movement, especially.
Yeah, you're going to want, depending on the application, how tight are you looking to be, right? Do you just want to know that something got above a certain temperature, or do you want to know what my temperature was throughout its entire journey with min-max averaging to the 0.1 C accuracy or lower, right? So typically in instances like this where we might build a custom tag for somebody, we're just an integrator. We'll use, some third parties temperature sensor, or it's built into a microcontroller or something like that, depending on the application and the cost, and kind of integrate with that to give them the performance they need. Because generally you don't know what you need. Like in most cases, you don't think you need crazy accuracy, but we've seen some very interesting applications for temperature monitoring with RFID that were very unique. I'll give you one example. We made a tag for, so at industrial ovens, they would basically, when they're doing batch cooking, they'll roll basically a tray into this gigantic oven, and they'd have a high temperature RFID reader at the top of the oven, and we would make temperature tags that went into each piece of food in the oven. So you're monitoring those temperatures passively. And the brilliant part of this, well, in my opinion, I thought this was pretty cool, was so it gets really hot in the oven, right? 400 F, something like more or more. But since the electronics lived in a hermetically sealed section inside the food part of the thing, they only got to the internal temperatures of the food. So 165 F, much more manageable from an electronics standpoint and survivability, right? So you're kind of using the food as sort of a barrier in that sense. But that was a really interesting application of a temperature tag that I would have never dreamed, something we would do, but very cool application nonetheless.
Right. Did they take them out after, or did people eat them?
No, they got taken out. They didn't look too appetizing. It looked like a big temperature fork kind of thing.
Yeah. So, I mean, obviously, pharmaceuticals and food are both very. You have to make sure they don't spoil. You have to follow regulations as you're shipping them. So how does this play into that in terms of the monitoring side of things?
Well, the bottom line is it gives the manufacturer, the shipper, whoever is, sort of responsible, the data they need to follow those protocols, right? So from our perspective, we're just an enabler, right? We're a power provider to satisfy whatever application you might need it for these logistic things. So from our perspective, you have the power there from these readers. So use it to get that functionality for free and provide that data to whoever's using it, because then they can use that data over time to target problem areas they might experience in their logistical chain that they have. Oh, we're seeing high temperatures on this leg of a journey or something, or in this warehouse, or it might tell you there's a problem with the HVAC system in some place too. So it gives you access to that data you wouldn't otherwise have. And that's we're just an enabler in that way. That's what we're kind of our view on how we kind of add functionality to the chain.
So is there a real-time element as well in terms of the tracking of the temperature or just location, any of these other types of things?
There's real time, and then there's also sort of logged data if that's what you want to. So for the tags that are completely passive, right, that are with some item on its journey, you're only going to get data from those tags when they're within that range of a RFID reader, right? So if you're close up, you're rolling down an assembly line or something where your RFID readers, the data at that point in time. So that's when you're there, you're getting that real time data. But if it gets thrown in a truck, there's no reader around. I mean, you don't know. And that's why we have sort of both flavors that we've done over the years, where if you do need that logged data functionality, you can enable that with a battery. And the pain point comes back again with the Stoop batteries, where, what do I do when that battery dies? Is it a one-use product? That's a lot of e-waste. Is it a rechargeable one? Well, that's logistically a big pain in the butt, where I've got, potentially tons of these tags. I got to plug them all in. It's just a logistical pain in the butt there. So if you can wirelessly recharge them, make that more seamless, simple, and integrated, then that process becomes a lot simpler to implement and a lot faster, costs you less, and you still get all of the same data you're getting that you would have gotten with just a battery in a single use kind of application.
So for shippers of sensitive products, is there a situation where then they need to be able to present that, this this temperature stayed, as you said, above a certain, or I mean, below a certain range, probably not above too much, but
I mean, maybe above if like start using it to like ship pizzas or something, right? That
There
if
you
you
go.
wanted a nice hot pizza, you want to know it didn't get cold on its journey, you could do it that way, sure.
Mhm.
But yeah, the big one that I always come back to is pharmaceuticals that need to stay chilled in their cold chain journey. You don't want something arriving where you don't know if it
Yeah.
went bad, right? Because that opens up a whole can of worms for tons of problems where you don't know what happened. If it did sit in a warehouse that wasn't temperature controlled for too long when it shouldn't have, you don't know. That's when that data becomes critical. And so anything that's sort of moving something that is that important, you're going to want that extra level of security, knowing that my product stayed where it was within the range it was supposed to stay in on its journey.
Yeah, which is going to be an issue with pharmaceuticals, but there's food products as well. At certain ranges that they don't want to get too high, and other times they don't want to get it too cold. They don't want the liquids freezing, because then when it unfreezes, there's a separation of ingredients and the taste goes bad. So there's all kinds of applications, but I can absolutely see the pharmaceutical as a key place for you.
I view it as like just as a cost thing too. So if you're paying for like a reefer container to send these things and it's not doing what it's supposed to be doing, you're paying money for something you're not getting too. So just to have that piece of data there going, hey, am I getting shortchanged? Do I have problematic containers? Just you have more insight into the product's journey that will inform how you move those goods.
Now, another issue that's out there, unfortunately, prominently these days is cargo theft, and so if you have these tags on the products, that seems like that could be something that could come in handy too if people were trying to research, problem areas where things slow down, maybe where things go after they are taken even. Has that come up in discussions at all?
It's come up in the context of security for the tags themselves, because you can use these tags to identify the specific materials. But again, if you have a theft or a tampering, those are concerns as well, particularly with airlines as well, with baggages, because a lot of airlines are using RFID systems to track baggage through their automated systems on the back end, where they need security. Like no one's moved this bag. I know where it is at all times. It hasn't been tampered with in any way. So we've done some work with British Airways. We made a tag for them that was a luggage tag, a digital luggage tag that worked on the back end and had additional security measures built into it with our technology, allowing basically that unless you were within range of a valid RFID reader, you couldn't alter any of the details that were stored in that tag. So from a security perspective, you want the ability not to change data, but you also need to log data potentially in its journey, so you know where it went last and you know where it might have gone missing. And then if you do recover it, basically, is this the one in question? Is this the shipment in question? So we see that less than probably just the standard tracking. You find, but depending on the industry you're talking about, that could definitely be something that is a very important part of their chain.
So you've mentioned some tags that have been able to handle somewhat extreme temperatures. So if it's in a container that we're not talking about temperature control now, but just a regular container that goes through different cycles of heat and cold and whatever. How confident can you be then that you'll get that data all the way through, following the product's journey all the way?
Well, it depends on what type, if you're implementing. Are you doing completely passive, or if you're doing battery assisted, right? Because the weak link I'm going to tell you right now is going to be the battery from a heat perspective. So let's say you got a container sitting there on the dock in the blazing sun. It gets hot in there. Mm-hmm. From an electronics standpoint, it's not hot, right? Those parts are rated for temperatures well beyond what you're going to see in a sealed container. But the battery, that starts to be a challenge, right? So you want to source batteries that can tolerate those sorts of environments. But the passive tags, which are predominantly what we see being used, right? They're the cheap option. They're the ones that are in, 95+% of things using these type of technologies. There's not really a heat issue from them just because the electronics can withstand so much. Honestly, it might be something more related to plastic, where you might actually get a softening of your plastic case, or whatever your case might be. If it happens to be plastic, then you might have, some heat effects from that. But from the electronics perspective, I mean, you could put these things, and we've done this here. You put them in a temperature chamber, let them run for a month, like you lost a container, right? It's just sitting there in the jungle, and they come out, all the data is intact. That data integrity is basically going to be there forever. So you don't lose anything unless it gets physically destroyed. You're in pretty good shape.
So in the supply chain side of things, the other piece that you mentioned with not wasting batteries as much. So using these and using the passive type, and especially, I would assume, to keep track of things, gather some data after the fact. I mean, you're eliminating the need for a lot of other potential products and waste that may otherwise occur, right?
I don't know that you're eliminating them. I view it as gaining additional insight or additional data, right? I don't know about you guys, but like, I like two sources of, confirmation sometimes with whatever it is, especially like if you're spending money on a logistical chain that's going internationally across, like, wouldn't you want to know just a little more data, especially when it's, relatively low cost to implement? Again, like you got RFID readers in all these warehouses for the most part anyway. It's like, wouldn't you rather know what was the travel time, really, reader to reader, left the dock, arrived at another dock, time it took from the time it told me it got there to the time it got scanned in? You could find inefficiencies in your factory lines and things like that with these things too. And that's some of our own products that we manufacture. We have built in UHF RFID simply for process control, understanding it moves from here to here. Well, why did it take a half an hour to move from station A to station B? There could be inefficiencies there that'll let you, increase your throughput or your yield or whatever. And now I forget what the original question was, but I'm just kind of, you know what I mean? Like you're gaining this insight, right? That could prove to be very valuable.
Yeah, I guess one piece that comes up is the sustainability question around using this technology. I mean, people are obviously trying to find ways to make things more efficient in any part of their supply chain. So how else does this help do that?
Well, the side of it that I like comes from the Powercast side, where, like I said, you're getting something kind of quote unquote for free because you're utilizing power that's already there that would otherwise not be used to do anything. So from that point alone, like, you're using more power than you were before. So there's an efficiency increase there at a, kind of a large scale. Now, that might not be overly significant, but the fact that you might not need batteries to get this, if you determine you need this information for whatever reason, and you want to implement it with wireless power, then you're inherently having the ability to eliminate that waste, whether it's the waste of the battery itself, whether it's the waste of the labor to go and change or replace that battery or to charge that battery, or the electronic waste that might come from, hey, this is a single use product that just gets tossed. That's really where the sustainability aspect comes in, is like getting rid of the hassles of the batteries themselves, the labor of them, the maintenance, charging, all that stuff that comes with the battery side of things.
So we've talked about temperature monitoring as sort of an over the top feature. Obviously, location, time. Are there any other ones that people have come to you and asked about, or others that you're working on?
There's some pretty interesting ones. Contact was one. So, was a switch closed, just to know the status of was a button pressed. Humidity is another one we've seen quite a bit, where, temperature is one thing. Like, if a cargo container is sitting there getting really, really hot, but humidity is a bigger killer, especially with, like, if it has packaging, paper packaging, something that's decorative, that stuff can't, I mean, all the colors start to run, the paper might get, loose, and the plastic kind of containing whatever it is gets basically destroyed. So you might want to monitor humidity. We've seen that a bit. Light level is another one we've dealt with quite a bit. If you're shipping film or something that can't get exposed to light, I'm sure there's more examples out there, but that's one we've seen quite a bit. And these aren't like exclusive to one tag, like one-to-one thing either. It's not like this tag does light, this tag does humidity, this tag. You can have one tag that does temperature, light, and humidity and contact all at once. It takes a little more power, so it might take a little longer, right, for that tag to be read and do its thing than it would have if it was just one, sensing element. But you can combine a lot of these things together. How about accelerometers or for vibe? Did something get rocked, right? Like your phone will tell you, like if you're in a car accident and your phone basically knows. You could do the same thing with a passive tag if you're in front of a reader. Did this thing get jostled beyond recognition when it was set down on a conveyor or something like that? There's all kinds of other examples we've seen, but I mean, straight up temperature is like the biggest one that I've seen that it consistently comes up. So that's why we talk about it the most.
Mm-hmm.
What about you guys? Have you seen other requests for things in the folks you've talked to for in these logistical chains?
Most of it has to do with temperature, whether it's too hot or too cold is really where people are going to. Now, Kevin did mention that, theft is a big concern, but you'd have to actually recover it to actually know where it traveled, because you have to be within, 10, or what did you say? 30?
Yeah, 30 feet of a reader.
30
yeah.
feet.
Yeah. For a passive tag. Yeah.
Yeah. So then it would be that play wouldn't actually work real well for what we're trying to do in terms of theft that occurs in supply chain. So yeah, it's absolutely temperature plus or minus, and want to be there, want to make sure is it freezing or is it going too hot?
Yep. That's the same experience I've seen from our customers.
And it depends. Some people want it to freeze, other people don't.
Yeah.
So
right.
Yeah, usually you spend your time trying to make things not melt, but sometimes you have to go the other way and make sure that it actually works when it's freezing cold too.
yes.
So one of the things that you see that you're associated with at Powercast too is this RAIN Alliance. So could you explain what that is and how it works?
So the RAIN Alliance is sort of trying to take the UHF RFID things and kind of rebrand it in a sense that it's very, I don't know, rebranding is the way that I kind of understand it, where they want to push this kind of as a more ubiquitous technology. UHF RFIDs, kind of a mouthful. When you just say RAIN would kind of be a lot like most people would understand NFC at this point, right? Mm-hmm. Where it's like near field communication. It's almost ubiquitous. It's built into every phone. You can scan all kinds of things that have these NFC tags in them. Well, same thing now, but for far field, long range UHF stuff. So RAIN is sort of trying to rebrand it in a sense that make it more ubiquitous, for all these different industries, because again, it can touch all kinds of things. It can touch the sort of the supply chain side of things too, but you see it in retail applications, on tags on clothing and whatnot. So it's really has the potential to be everywhere. And I think they see that. So they're trying to rebrand it such to make it the similar to an NFC.
Is there a payment kind of optionality there too? I mean, obviously that's one of the things that people think about with NFC also.
There is. So the advantage NFC has, right, is that you have to basically be in contact with something. So that's an inherent built-in security feature of it. You could argue it's also a limitation, because it is, right? It only works where you're really close, but also you have to be really close. Part of the challenge with NFC and by association also UHF is if I drop my NFC card, say you're on a cruise and they give you a card, right? That's your access to your room. That's how you pay for whatever. And there's NFC technology in that. If I drop my card and Kevin, you pick it up, you're me basically now. Yeah. So, and this is a little off of the UHF side of things, but one thing we can do with wireless power is we can harvest from NFC sources too. How about you add a biometric element to your NFC tag? All right, so now I have a fingerprint sensor on my NFC tag that is completely passive. So I can scan my thumb, and I have to scan my thumb prior to authenticating something, where you've eliminated that as a security risk. You could do the same thing with UHF in the far field stuff. The problem is far field stuff works far away. So, different strokes for different folks, but it's totally possible too. Like far field is supposed to work far away. So I don't know that you want to read security information or something that critical. If you have a crowd of 100 people, you're going to have all that information flying around. I don't know about you. That doesn't make me too happy.
Yeah.
No.
So, I guess the company's been around for a bit. What's sort of next on the horizon there for use cases?
The RFID stuff is going strong, right? So we're actively manufacturing millions of units for a couple of key customers for ours. So we don't see that slowing down. And from an RFID standpoint, that is actually relatively low volume, but these are sort of end products. So that's pretty cool to see. But like I kind of stated at the beginning, we introduced it at the Consumer Electronics Show this year. We're adding magnetic resonance. So that's sort of the new leg of our stool for the wireless power products that we're offering. And it's cool because I think of it as like NFC, or I'm sorry, the coil to coil chi-based stuff plus, because you get Z separation, so much more physical distance away from a coil, significant amounts of power transferred up to 100 watts, and so much more freedom of placement. Where if you've ever used a Qi charger with your phone, you got to set it right down, kind of align it well, and then it works great. Mm-hmm. But if you bump it, it disconnects, and then you're frustrated when you come back and it doesn't. That with the magnetic res, that doesn't happen. You can slide it across the table, you can move it across your countertop, doesn't matter, and you're still getting that full charge to it. So that's the exciting new stuff we're working through now, getting development kits ready to kind of present to folks. So that's kind of the new core technology that's exciting for us right now.
And in terms of regulatory things of that nature, is that something that is constantly being looked at? Is there, obviously there's health and all sorts of other elements that they're considering, but where does that stand?
Good question. I said at the beginning that the number one question I get is, can you charge my phone?
Yeah.
The second question I get with the RFID stuff is it safe? And I always say the same thing. If you are comfortable using a phone, the exposure you get from these reader systems are orders of magnitude lower in terms of exposure. So they're all FCC approved. We help our customers get through the regulatory process for FCC certification for whether it's a transmitter device or a receiver device. So basically, we're subject to the same rules that every other wireless device out there is subject to. So Wi-Fi routers, same thing as us. So I always say the same thing. If you're comfortable with the phone, you should be more than comfortable using this wireless technology.
Great. So where can people go to learn more?
Definitely our website, number one. It's powercastco.com, powercastco.com. That all of our latest information, our press releases, what trade shows we're going to be attending, information about our products. But even then, if there's something custom, I always encourage people to reach out to us directly, because what you see on our website is basically just the tip of the iceberg. We're a relatively small company, but we have a breadth of skill sets and manufacturing capabilities where we make chips. We sell chips through distribution, and sophisticated customers like a Samsung can go buy chips and go implement them, and off they go. But I'd say 95% of the time, we're doing custom design work for our customers, whether that's just an antenna design for them or designing their circuit board. But we'll do full white labeled product designs in the millions of units, manufacture overseas, ship it around, be their sort of logistics arm for them too. So depending on what level you want to engage or what level you're comfortable doing, we can cover the whole thing. So if you have something in mind that you're interested in wireless power, you're not sure, always just reach out to us, because that's how 99% of our customers start.
Great. Eric, appreciate you taking the time.
Thank you. This was fun. Anytime you want, I'm happy to come back on.
All right.
Thank you.
Thank you.
Appreciate it.
I actually just watched over the weekend a movie on Amazon called G20, where they were tracking hotel guests with RFID tags. So I didn't bring that up on in this conversation, but it's just funny timing that we're talking RFID, and it's a middling action movie, but all right.
Yeah, well, I didn't ask the question in terms of, you're on a cruise ship, and the cruise ship, you have a tag on you and you're walking all around. They know exactly where you are. You can find your friends, your family associated with that. You're scanning things to buy it. But I never thought about it, but that could be another use that's being out there that people are getting tracked in.
Yep. But yeah, this is just an interesting way of gathering more data in a relatively simple manner, I think. Just another way of having it's not just confined to the warehouse. The warehouse is certainly a very obvious use case for it, but you can, bring it with the products all the way through.
Yeah, absolutely. If the technology got to the point where the RFID could be read from a further distance, I can see tons and tons of applications, but it's a little bit limiting at this time, but technology changes and I can see that happening. And it would be a game changer in a lot of different areas.
I had to ask if they ate the RFID tags. I mean, maybe you could make it.
I was thinking the same thing, but anyway.
I just got I had to do that. Yeah. I had to do it there. I mean, maybe, he talked about plastic as being one of the materials. Maybe there's some sort of edible material that you could.
There you go.
Maybe next time. Right?
Okay,
we'll talk about that next time.
That's another topic for another podcast.
Yeah. At any rate, speaking of other podcasts, you can get all of our podcasts on YouTube or any of your favorite podcasting providers. And please do rate and review us wherever you do watch or listen to us. And you can also email us at podcast@intechlogistics.com to ask us any deeper questions that you want to take offline and get a little bit lengthier response. We are happy to do that as well. Again, thanks to Eric for joining us for this episode. And you can learn more about Intech Logistics at www.intechlogistics.com. Please do come back for the next one. Rick, thanks very much.
All right. Thank you.
We'll talk to you soon.